In Veggies Corner, we're going to look at how many solutions there are in a linear system. So what does that mean? Well, when we graph a linear system, where the lines touch, that's the point of intersection, right? So that's the solution of a linear system. Now, it's not always that easy. They might not always touch. So the number of solutions in the linear system is determined by the number of times they do touch. So most of the times of the examples that we've seen, it has one solution, meaning you graph the two lines and they touch in one spot, right? They touch in one spot right here. So what happens there is when you graph those lines and you put them in slope-intercept form, they would have different slopes, right? The angle, the rate of change would be different. And the y-intercepts can either be different, or they can be the same. So they touch just once. Now, in this second example, in these two lines, they're parallel lines. So they don't touch at all. There's no solution. Now, how do we know that lines are parallel? Well, they have the same slope, right? The rate of change is the same, kind of like a railroad track. And they do have different y-intercepts. So in that case, they're not touching at all. So there's no solution. Now, the last example is infinite solutions, meaning there is an infinite number of opportunities for them to touch. Basically, they are the same line. So I would graph one line, and then I would graph the other line, and they would be right on top of each other. Now, we know that there's arrows on the end, so they go on infinitely in either direction. So they're the same line, meaning if you put them in slope-intercept form, they have the same slope and the same y-intercept. So one thing that I kept saying over and over is the easiest way to determine the number of solutions in a linear system is to place them in slope-intercept form, because you need to compare the slope and the y-intercept. So now you could graph them once you have them in slope-intercept form and kind of give a good visual for you, but you don't necessarily have to do that. So let's look at some examples. So we know that slope-intercept form is y equals mx plus b. And the question says, how many solutions are there in the given linear system? So we're going to put all these equations in slope-intercept form. So in number one, I'm going to add 2x to the other side, right? Because I want to get y by itself. I'm going to divide both sides by 4. And I end up with y is equal to 2 over 4 simplifies to 1/2 x plus 1 over 4. Okay, I'm going to do the same thing with the other equation. I'm going to bring that 3x to the other side. I have negative 6y is equal to negative 3x plus 9. Again, I'm trying to get y by itself, so I divide both sides by negative 6, all my terms, and I have y is equal to. Now, negative 3 over negative 6 simplifies to positive 1/2 x minus 3 over 2. Okay, so now that we have both our equations in slope-intercept form, the first thing we're going to do is we're going to compare the slopes. And we do notice that they're the same 1/2. But we do notice that the y-intercepts are different. So what these are parallel lines, right? Parallel lines. And when the question says how many solutions, in this case, there is no solution because they do not touch because they're parallel lines. Okay, let's look at the next example. We're going to do the same thing. I'm going to bring 2x to the other side. I want to get y by itself. So I have negative 2y is equal to negative 2x plus 4. Divide both sides by negative 2. And I have y is equal to negative 2 divided by negative 2 gives me positive 1. So that's 1x. We just write x minus 2. We'll do the same thing with the other equation. I add x to both sides. And I have y is equal to x minus 2. Now, if I look at those two equations, I notice they are exactly the same. So again, that means they're the same line. If I were to graph them, they would be right on top of each other, right? The slope's the same, the y-intercept's the same. So in this case, there's an infinite number of solutions, because they are going to touch infinitely number of times because they're the same exact line. All right, let's look at the last example that we have. Again, the same thing. I'm going to get y by itself. I'll bring 5x to the other side, and I have 3y is equal to negative 5x plus 17. Divide everything by 3. And I have y is equal to negative 5/3 x plus 17 over 3. And looking at our next equation, same thing. I'll get y by itself. So I have negative 3y is equal to negative x minus 2. Divide everything by negative 3. And I have y is equal to, that gives me positive 1/3 x plus 2 over 3. Now again, when I'm looking at my slope, here's negative 5/3 and here's 1/3. So right away, when I see that the slopes are different, right, my rate of change is different, I know it's somewhere they're going to touch. And when they touch and it's not the same line, they only touch in one spot. So there is just one solution. Okay, thanks for stopping by today. You have a great day.